Okay, so this is one with the ball rising to the top of the trajectory, okay, without air resistance, all right? So if we say we're going to ignore air resistance, which we do a lot of the time, then that means we're not even going to include the air, okay? All right, so as I throw a ball upward, okay, it's going to slow down. So you can kind of see here like these little markings, right? So if it's going to slow down, we know that that means the forces have to be unbalanced, okay? All right, so I'm going to have just the ball, and I have the earth, and that's it, right? There's really nothing else, okay? So what a lot of people want to do is you want to think about, like, well, how did the ball even get there? Like, did someone throw it? Was it, like, launched from a cannon? We don't know, and we don't really care, because we only care about the position that it's shown in, okay? So at some point, it had to get launched from somewhere, but we don't care about that, okay? So all we have is the ball in the earth, so that's a gravity. And we're going to ignore the air resistance. So look, that's it. This is an easy one. Okay, remember, I'm always going to put FG first, ball, earth, and that's it. That's all that there is. Okay, so remember that some people, okay, were thinking about, we have a force that's pointing down, okay? And remember that force does not tell you about motion. It tells you about change in motion, okay? So some people feel a little confused that the ball is moving upward, but yet the force on it is downward, okay? So just think about it in terms of the bowling ball, right? So like if I had, draw out the path of this, right? Like every second, like one of those little motion diagrams that we did, okay? Right? The ball would kind of go up over here, and then it would come down over here when I throw it up and back down. Okay? The force on this ball is the same all the time, right? The force is just the force of gravity, because this interaction diagram is going to look the same no matter what the ball is doing. Up, down, top, bottom, side. We don't care, right? There's nothing else to interact with it except for the earth. Okay? So if you think about what we did with the bowling balls, right? When something, say, would be moving up, but it's getting pushed down, that's going to make it slow down, right? Because it's working opposite, the force is working opposite the motion, so it's going to get slower, okay? But on the other side, when it's on the way down and the thing is moving down and also being pushed down, that's the same direction, it's going to get faster, okay? So this is the force diagram for everything that's in what we call free fall, only under the influence of Earth's gravity. Nothing else is happening, okay? So it doesn't matter if it's on the way up, on the way down, at the top. This is the same diagram, okay? Because the change is always happening downward. It's either slowing down or speeding up, depending on which way the ball is moving.